Hi friends, today we are going to discuss about Einstein photoelectric equation from the chapter Dual Nature of Matter. Okay, Einstein explained the photoelectric equation based on quantum theory. Okay, according to quantum theory, light radiation consists of tiny packets of energy. According to quantum theory, light radiation consists of tiny packets of energy called quanta. It's called quanta. Okay, and one quantum of radiation is called photon. One quantum of radiation is called a photon. So according to Maxwell quantum theory, light radiation consists of tiny packets of energy. We call it as quanta, and one quantum of light radiation is called photon. This photon have an energy that is E is equal to h nu. The photon have an energy E is equal to h nu. Here h is Planck constant and nu is the frequency of incident radiation. Okay, so this is the quantum theory. Based on this concept, Einstein explained the photoelectric radiation or photoelectric equation. Okay, based on this concept, Einstein explained photoelectric equation. So he considered a radiation. Having energy h nu. We consider radiation and one quantum of radiation having energy h nu that is incident on a metal surface. Okay. A photon of energy h nu is incident on a metal surface. Okay. So on the surface of the metal surface, many electrons are there. The electrons will gain the energy in order to overcome the work function. So it will be emit electron, and some of energy is utilized to increase the kinetic energy. That means when a photon of light radiation is incident on a metal surface, that energy is utilized by two processes. One is to reach into the work function in order to gain the energy to overcome the work function, and another part is used to increase the kinetic energy of the emitted electrons. So when a photon of energy h nu is incident on a metal surface, that energy is utilized by two way. One is to increase the kinetic energy of emitted electron, one is to overcome the work function. So you know what is work function? So work function is the minimum energy required to remove an electron from the metal surface is called work function. Okay, according to the conservation of energy, we can write h nu is equal to half mv square plus phi 0, because h nu is utilized to increase the kinetic energy and overcome the work function. So we can write h nu is equal to half mv square plus phi 0. Here half mv square is the kinetic energy of the emitted electron, and phi 0 is called the work function. And h nu is the energy of incident photon, and we know that phi 0 is equal to h nu 0. And here nu 0 is called threshold frequency. So I am going to rearrange the equation like this. From this equation we can find the kinetic energy of emitted electron. From this equation we can find the kinetic energy of emitted electron. The kinetic energy of emitted electron can be written as half mv square is equal to h nu minus phi 0. h nu minus phi 0. But we know that what is phi 0? Phi 0 is equal to h nu 0. So instead of this phi 0, we can substitute h nu 0. So we can write half mv square is equal to h nu minus h nu 0. Half mv square is equal to h nu minus h nu 0. This is called Einstein photoelectric equation. Here half mv square is a kinetic energy and h nu is energy of instant radiation, and h nu is 0 is h nu 0 is the work function. So we can write this equation like this. Half mv square is a kinetic energy. We can write it as K max. Maximum kinetic energy is equal to h nu minus h nu 0. K max equal to h nu minus h nu 0. So this is called the Einstein photoelectric equation. Next we are going to discuss about law of photoelectric emission based on Einstein equation. Okay, now we are going to explain law of photoelectric emission based on the Einstein equation. K max equal to h nu minus h nu 0. K max is the maximum kinetic energy, h nu is the energy of instant photon, and h nu 0 is the work function. Okay, so the first point from this equation, if one photon is incident on the surface, metal surface, one photoelectron will be emitted. That means if number of photoelectron will be emitted per second, the number of photoelectron emitted per second depend on the number of photon incident on the metal surface per second. Okay, the number of photoelectron emitted per second is related to the number of photon incident per second. That means the intensity of instant radiation depend on the photocurrent. Okay, the intensity of the instant radiation is increases, the emitted photoelectron will be increased. That means the photocurrent will be increases. That is the first point from this equation. That is saying that the number of photoelectron per second depend upon the number of photon falling on the metal surface per second. Okay, that is the first point. Okay, so that means the intensity of instant radiation is depend on the photocurrent. Okay, the next point, if we consider the frequency of instant radiation, is less than nu 0. Nu 0 is called threshold frequency. According to the equation, we get K max will be negative. The second point, if nu is less than nu 0, nu means the frequency of instant radiation is less than the threshold frequency, the kinetic energy, the maximum kinetic energy is negative. It is impossible. That means in order to emit an electron from the surface of a metal, a minimum frequency is required. That is called threshold frequency. If the incident radiation frequency is less than the threshold frequency, there is no emission of photoelectron from the metal surface. That is the second point. And third point, if the nu is greater than nu 0, the frequency of instant radiation is greater than the threshold frequency, according to the equation we can see that K max will be positive. Okay, kinetic energy will be positive. That means the kinetic energy of emitted photoelectron depend on frequency. If frequency of instant radiation is increases, the kinetic energy of photoelectron is also increases. That is the third point. That is the third point from the photoelectric equation. And last point, here the photon and the electron are head-on collision. Photon and electron are head-on collision. That means the photon energy directly given to the electron, and electron acquire the energy, and it will be emitted from the metal surface. That means there is no time lag between the incidence of the photon and emission of photoelectron from the metal surface. That means there is no time lag between the incident radiation and emission of the electron from the metal surface. That is the last point. There is no time lag between incident photon and ejected photoelectron. So these are the laws of photoelectric equation, or law of photoelectric effect based on Einstein photoelectric equation. What is the first point? The first point says that the emission, or otherwise we can say that the photocurrent is depend on the intensity of incident radiation. And second point is that a minimum frequency is required to remove an electron from the metal surface. That minimum frequency is called threshold frequency. If the frequency of incident radiation is less than the threshold frequency, there is no emission of photoelectron. Clear? Next point is, if frequency of incident radiation is increases, the kinetic energy of emitted electron is increases. And the last point is, there is no time lag between incident radiation and emitted photoelectrons. So these are the conclusion from the law of photoelectric. These are the conclusion for law of photoelectric effect.